Elkilany. We are team Embed-dead systems. We are doing the smart attendance project. My name is Omar Hesham, and I will be introducing our project. Keeping attendance can be a hazard in the classroom. It can waste a lot of time and effort of both the teachers and the students. And it can have problems with human error and violations such as a student taking attendance for their friend. But with our system here, instead of calling out names, each student can simply swipe their RFID card on the RFID card reader. Instead of, if a student is late to the class, instead of interrupting class and asking the TA for attendance, they simply swipe their card. Our system outputs the log to a log file stored on an SD card. When the session starts, as in the teacher scans their RFID card, our system outputs the date of the start of the session to the log file. And throughout the session, it tracks the attendance of each student. When the session ends, by teacher swiping their card again on the RFID card reader, it outputs all the students who attended most of the session. Our threshold is 75%. It outputs their name, their ID, and the time they attended of the session in percentage, and it outputs the date of the end of the session.
Hello, my name is Ahmed Darwish. I was responsible for the hardware components and connections of our system. So as you can see, our system's main brain is the Arduino Uno. It's responsible for interfacing the different electronic components we have in our system, as well as taking different inputs and outputs. So we will go over the different data components one by one. So we first have the smoke detector. It's responsible for measuring the intensity of harmful gases in our system. If the amount of gases reaches a certain threshold, the Arduino outputs an output signal to the buzzer, which signals out an alarm. The buzzer is also responsible for giving feedback when the card is swept on the reader, as you can see right now. After that, we have an LCD. It's responsible for showing the count of students inside the classroom, as you can see here. It also signals whether a tutorial is going on or not, as you can see now. So as you can see, a tutorial is in session right now. Then we have the SD board. It's responsible for writing files and reading files from the SD cards right here through the Arduino board. We also have the RFID card reader. It's the most important component in our system, as it's responsible for writing data and reading data from the MIFAR RFID cards. Last but not least, we have an LED. The LED is responsible for simulating a door opening and closing. So for example, if somebody wants to go in, we just do this, and it will light up for a second or two till the person goes in and out, and so on. We can simulate when a fire goes on. So for example, if right now, a fire is on in the system, the door remains open, and the word fire is written on the LCD.
My name is Nesrin Abdulaziz. I was the one responsible for the RFID card reader. As my friend Darwish said, that we used this RFID card reader to handle all the writing and reading of the cards. The cards were first used to write data on them. The data was names of the students. This was done by using an online library that handled the functionality of reading and writing to the RFID cards. When writing the names, we considered the names of the students as the unique IDs, but of course, when in deployment, we can use the manufacturer UID card, UID in order to indicate the ID of the card. So when a card is present at the RFID, we check if there is a new card that hasn't been yet read at the RFID reader, and then after finding that there was a card, we use authentication to authenticate that this card is a valid one, and then after authentication we read the data written on the card in a buffer. This buffer is later used by the logic of the handling attendance in the software part. We have two different kinds of cards. This type of cards show that this is a teacher, so they have the signal that a teacher entered the room, and this type of cards showed that a student entered or left the room. As for the pins used, the pins of the RFID card reader are the reset pin, the MISU, MISU and MUSI, and SDA and the serial clock. The serial clock and MUSI and MISU are common with SD card reader, so they were handled as hardware, and that's it.
Hello, my name is Omar Elkilany. I was responsible for the attendance logic with Omar Osama. Our logic keeps track of the students inside the room, and also keeps track of the time when the teacher enters and leaves, so that the session times are recorded. Let's first go through the main scenario of our logic. The scenario starts when a teacher arrives with a RFID card corresponding to a teacher. He then places it on the RFID reader. This records that the session has started, and we retrieve the actual time right now, and we store it for reference so that this is the starting time of the session. Then, whenever the teacher leaves the room, the time is also recorded for further calculations later. Now, in the middle, or even before the teacher enters, a student can enter the room. This student flashes his RFID card in front of the RFID reader, and the door opens for him, and we increment the counter that keeps track of the number of students inside. Then we check if this student is leaving or if this student is entering. If he's entering, then we record the start time when he entered, so that we can use it later for calculations. If he's leaving, then we retrieve the time at which he's leaving, and we subtract the time of the leaving from the time of the entering, and we add the value to an accumulator. This accumulator stores the total time that the student spent inside the room, and at the end it's used for calculating the attendance using the appropriate threshold. Okay, so now let me pass another student into the room. The count will increment. And similarly, the student will have his own unique ID stored inside, along with the time in which he entered. And this value will be used for calculations unique to this second student alone. Thank you.
Hello, I'm Omar Osama, and I handle the attendance keeping part with Omar Elkilany. So after a session ends, we call the getAttendance method, which calculates the total time of the session using the start time of the session when the teacher entered and the end time of the session when the teacher left. So then we output the attendance data to the log file on the SD card. So the way that works, we check for all students that have attended any portion of the session, and we check if they have passed the threshold for attendance. Then we output their ID and the percentage of the session they attended on the SD card in the log file. So, in case a student stays in the room after a teacher leaves, then the system keeps track of that student until another teacher enters the room, starting another session, and then that student can get attendance as if they have attended from the start. And if the student attends a session and the teacher leaves, and then the student leaves the room before another session starts, then the student is discarded, and we don't keep track of them in the system anymore. Now, in the case of fire occurs, the attendance keeping functionality is halt, and the current session data is not stored on the log file anymore. But the previous sessions attendance data that were previously written out to the SD card are still there. Our system had some limitations, the first of which was the amount of memory available on the Arduino Uno board. So due to that, we could only keep track of 40 students at a time, which is a reasonable number of students for a classroom. The second limitation is the number of hours the system can keep on running. We can only keep the system running for 18 consecutive hours. After that, the system would require a manual reset. But we do also think that 18 hours is more than enough for a full day.